Hi, welcome to today's training. It's very nice to meet you all in person here in our headquarters. My colleagues delegated me to warm you up before the big gun, the EMU PRO. So during my part of the training, you will learn about our brand new data analysis software, Data Master. But before we start, I'd like to quickly introduce myself. My name is Michał Kowalski. I joined ECUMASTER company 2 years ago. I'm the main developer of the application. Previously, I was dealing with all kinds of analytics, ranging from quantum mechanics. So, without further ado, let me place the Data Master in some kind of a context. So, with our devices, we gave the users big logging potential. So, for example, the ADU lets you gather a lot of data, but the thing we were missing was the last part. So, from the sensors to logging, that is covered by us, but what to do with the data gathered. We had some features in our software, but they were fairly limited, and the customers demanded more. I don't think I need to convince you about how the data can be a very powerful tool, both when identifying issues with your setup, with your car, but also when extracting more driver potential. So, Data Master is the answer to the last part. It should be a response to the growing demand from our customers to analyze the data in depth. Data Master supports all our logging devices. What is important, you don't need any project, you just need the log, and all the data, such as the user-defined channels in the ADU, will be loaded automatically, so you need just one file to analyze the data. Of course, we don't support just the ADU or the PMU, we support also the engine data from our ECUs, including the brand new EMU PRO. When designing the software, we had some key concepts in mind. We wanted to give the user a powerful tool, but keeping it as simple to use as possible. So this tool is suitable for both track day amateurs, but also for professional racing teams, because we already supported the software to some of them, and they found it very useful. We know that our devices are used in all kinds of motorsport, not only circuit racing, and we all answer also this need because we have predefined projects for multiple types of motorsport, including not only circuit but also drag racing, dyno, and rally data analysis. My goal during this training is not to describe every feature of the Data Master, because this is something you can read in the manual that is available on our website. Instead, I'd like to point some key concepts and the general workflow with the software, so you know how to use it, so you know what is in there. And we will start with the basic concept of the project. Then we will talk briefly about how to manage logs, how to load them, etc. Then I will overview all the panels, all the visualizations that we give to the user. I will focus on the application of the different kinds of visualizations. And further, we will dive a bit deeper into more advanced features, such as mathematical channels, aliases, and constants. Furthermore, we will talk about the possibility to adjust how the log was split automatically, because that is sometimes the issue we have with the GPS, with the user not setting the start-finish line properly, and previously the log was useless, basically, after it was not split into laps. But here we give the user the possibility to override this automatic split and to split the log as the user wants it. And last, I will sum up what are the differences between different project types. So, the first key concept of the software are the projects. So, They help you to organize the data, the way you work with them. And a single project stores this information. So the desktops, the panels and how you set up, the paths to the logs and the videos, the user-defined mathematical channels, and the user data. I will talk in a second what the user data really is. So basically, the idea is you can pick up where you left. So you close the software, and then you can start exactly from the point that you were on, with the same logs loaded, with the same video files, with the mathematical data you created, and so on. So let me show you how it works in real life. So this is the window that welcomes the user. On the left, we have the projects that we created recently, and on the right, we can create a new project. During our today's training, I will focus on the circuit, because that's the case that most customers use the software for, but we will then summarize all the different types in the end of my speech. So we create a project, let's call it Data Master Training, and we can start. So as you see, the layout of the desktop is already predefined, so the user doesn't start from blank. Now, let's talk how to manage the logs, because that's the core of the data analysis, right? The data. So I will load the log. And as you can see, the window on the left is populated now, and the reference track is automatically generated. So let's focus on this window for now. This is the log manager. So as the name suggests, it manages the logs. If we have multiple logs loaded, we will see all of them here. We can see what were the lap times, what is the delta to the best lap, and we can exclude, for example, those 3 slow laps. This is the log from the race, so maybe something unexpected happened. We can exclude from the general statistics these 3 logs, or we can keep them depending on the situation. This panel also lets us select the laps for the comparison. I will show you how it works in a while. Oh, I forgot to mention one thing. What is a neat feature of the projects is that you can very simply transfer your work to other users or to other PCs. So there's a concept called an archive, and basically it packs all the project, excluding the video, not to increase the file size too much, into a single file, which you can then transfer and unpack, and basically the user receiving the project will start from where you left off. This gives you a lot of possibilities. For example, you analyze the customer data from the engine or from the track, you make some notes, you make some mathematical channels, then you pack the project, send to the user, he just opens it, and everything is contained in the archive. Then I talked already about how you manage logs. You can change the order of the logs from the log manager, you can delete a single log, and do all kinds of stuff with it. Now, I think you are all aware of the concept of panels, such as in the ADU, the PMU, or in the brand new EMU PRO. So basically, your workspace is split into panels. You can move them around, replace, add new, delete some of them. but basically it keeps your workspace organized. Now I will briefly discuss every panel. So I think we all agree that the graph log is the basic panel for all data analysis. So it plots all the data in the function of either time or distance and makes all those famous squiggly lines. The core concept of the graph log doesn't differ much from our other software, such as EMU Black or the ADUs or the EMU PRO. However, it's expanded, it's more advanced, it gives you much more features. So I will now jump to the software to show you how it works in real life. On top, we have the lap axis. So just by looking at the log, you already know if there is something interesting, like this drop in the RPM, you already know that was lap 6. So you can remember that there is something interesting in there. You don't need to remember the exact timestamp. You can click on the lap to focus in and see the data in more detail. What is important is the concept of the cursor. So basically, all of the panels in the software are integrated. When I have the cursor on a specific data point, the cursor is set at the same time or distance in all of other panels, such as here. We have this point highlighted because this is the point corresponding to this cursor. So basically, the software is integrated and the panels interact with each other. Okay. We have the value axis on the left side. If we overlay multiple channels at the same graph, such as in this example, so we have RPM and TPS. Not to mess with the visualization, we have basically two axes on top of each other. So here are the values of the RPM, and here is the value of the TPS. Because in other case, we would have the values from 0 to 100 very small, and the values from 0 to 7,000 extremely stretched, and we couldn't differentiate the TPS. Of course, if the user wants to, he can come back to the native behavior, such as in the other softwares. It really depends on the situation. I already highlighted that we can compare laps. For now, we can compare two laps, but we will change and expand it in the future, so the user can compare more laps. We select the laps to be compared from the log manager. In this case, I'm comparing the best lap, highlighted in green, in the second best lap, with the second best lap, because the delta in the delta column is the smallest, right? Oh, it's actually not, but you get the point. Now we can analyze the data in the time or the distance domain. Of course, for most cases, we compare laps on the base of the distance covered to overlay the same points on the track. We can identify some issues. For example, on the best lap, theoretically best lap, you can see the driver started to brake much earlier. And we may want to highlight to the maybe future us or to the driver that this is something worth investigating. We can select this part of the track. As you can see, The other panels responded to the selections, drawing only the selected part, so you get only those points that you are interested in. And we can add a bookmark. So a small note highlighting this is something that was unexpected. I will add the bookmark. We can enter the title, for example, braking too early. And now we can expand a little bit on the message to ourselves or to the driver. Right? We can then select the level of severity, because this one is just an information. But if we had a very low oil pressure in a corner, this would be not an information, but rather an error or the warning. So this will be differentiated later. And now we have the bookmark. Okay, something odd happened here. Okay, the braking was too early in this part of the truck. Just for the sake of the example, I will now make the bookmark with higher level of severity. As mentioned, let's use oil pressure. Oh, it was low in here. We can select the part, low oil pressure. As you can see, it's marked in different color, right? So at the first glance, we see this is way more serious than this one. But the key concept is our ideas that we extracted during the analysis will not be lost, right? They will be saved in a user data file, and it will be stored together with the log. So if we open this particular log in different project, the data we marked will be marked as well. So this is bound to the log, not to the project. Okay, let me just go to the... Yeah, I think I covered all of the features. Oh, there's one that I didn't mean. So if we have the selection active, we have the feature called the reference cursor. So we can see the delta between the start of the selection and the finish of the selection. So in this 250 meters, the faster lap gained 27 kilometers per hour, while the slower lap gained 24 kilometers an hour. So we can use it to compare like the ranges, not only specific points, but we see the value in the base point as well, so we have the concept, we don't lose it. Let's now go to the next panel, the bookmark overview. So, as you've seen, I implemented 2 bookmarks, and now there are only 2, but there may be more. Like, if we have a long log and we did some in-depth analysis, this would be multiple, not just 2. And if we want to, we can double-click on the bookmark, and we will jump right to it. So we can move from bookmark to bookmark and discuss only the things that are important. We don't need to look through the log once again. You know, the time is ticking. We have 10 minutes to the next session, and we just, oh, where was it? Where was it? We have everything in one place. We can move from one important point to the other without losing time to seek for the data. And we can sort the bookmarks by severity. So, for example, to start with the most important ones and then gradually come to the less important. The next panel I would like to talk about is the channel report. It doesn't draw all the squiggly lines that I mentioned before as in the graph log, but we see the channels, the value in the point highlighted by the cursor, the minimum value in the selection or in the whole log, depending on if the selection is active, and the maximum value in the same range. So either the selection or the whole log. We can, for example, see the maximum CLT. We load 3 hours of the EDL log, right, from the long run, and we can just in a split second see what was the maximum CLT value, for example. We can see all the different data. We can select, for example, the corrections. So let me replace with the channel report. Now we add channel and we filter correct. Okay, I don't have the corrections in this log, sorry. But let's say errors. If we now see the maximum value, we can see if it would be all zeros, it would mean that there were no errors during the whole log. But we see that there were some errors, and we can look it up, check what was going on. Same with the corrections, right? We can check if the corrections were active. We had a situation during our endurance racing that we had a very high fuel consumption on the lap to the grid, and this would basically cost us the race because the consumption was way higher than expected. The strategy would be basically useless. And we were able to identify in a split second that the correction that shouldn't be turned on, because it was the IAT correction, was turning on and making the fuel mixture richer, meaning we were burning a lot more fuel than expected. So it's a way to quickly overview a lot of data or a lot of channels. Next on, the panel that I think is familiar to you. It's very similar to the one found in the ADU. It's the GPS track map. It basically draws either the reference track generated from the GPS data or the raw GPS data itself. We can use this panel to, for example, identify any issues with the GPS module, right? Or we can see the trajectories on each lap, the racing lines. If we are in lap compare mode, we can see what were the lines through a corner on specific laps. So this gives you a more in-depth look at the data, because sometimes it's hard to define why specific lap was slower or faster. We can see that, for example, the speed in the mid-corner was higher on a particular lap. But why? By looking at the trajectory, the line through the corner, we can estimate, okay, you turned in a bit earlier, as in the red example, right? The white could have a bit overshoot the corner. In the future, we will have the track map, like the satellite image of the track in the background, so we can see the lines even more directly on the track. The next panel, the next visualization available is the histogram. It works as a histogram in Excel or other software. So basically, you have the bins on the x-axis and the frequency of the occurrence in the y-axis. Of course, when we think about histograms in data analysis, we automatically think about suspension histograms, suspension velocity histograms to be exact, but we can analyze more data than we think with the histogram. For example, on this image, we have the histogram of the RPM. This can be useful because we can see that the most time was spent in this region. And for example, we can look up the power curve gathered on the dyno and see if the driver was spending most of the time in the most efficient range. Maybe he was, for example, shifting gears too early or too late. This is the way to see it clearly in the statistical view. As in this example, we can define the RPM as I mentioned. We have a bunch of settings here. It is really specific because sometimes we don't want to have the bins auto-scaled. We want a specific number of bins or specific width of the range, the width of the bin. So this really comes to the particular case, but we have a wide range of personalization in this panel. If we then exclude the in-lap and the out-lap, which, as you can see, though the out-lap was really driving those low RPMs up because there was a lot of idling, a lot of standing still with the motor turned off. So this is the case where we want to exclude some laps, especially those out and in lap, because those are not the ones that we are interested in. So we exclude these laps that are not meaningful. And we can see that the driver was using mainly the range of the RPMs between 5 and 5,500 RPMs. This may seem low because it was a very wet race. So this differs a bit from the standard dry race where we would like to keep the engine revving a bit higher. But if it was, for example, the amateur driver and he would have a habit of shifting too early, this would be the panel that would show us that the driver is not using all the engine power available to him. My personal favorite, run chart. Why do I like this particular visualization so much? I'm really into endurance racing. Long stints, a lot of data. We need a way to quickly identify some trends, some issues, and this is the way to do it. So all the data points from one lap are aggregated into one single data point on the chart. For example, here we have a lap time versus lap number. So we have lap number on the x-axis. This is always the case in the run chart, but we can define what is shown on the y-axis. In this case, this is lap time. So as you can see, the lap times were basically all over the place during this relatively short race because it's just 10 laps of racing. What was the cause? Maybe the driver was inconsistent and looking for new lines. Maybe he was in the middle of the pack fighting. You know, you don't take the best line when you fight with somebody. Or maybe there were some issues with the car. For example, it lacked power on this slow lap. It's a starting point for the more in-depth analysis. We can basically aggregate any data we want on this particular panel. Let me, here we have the lap time versus lap number, but we can select any metrics we want. We can see what was going on with the oil pressure and see what was the minimum, maximum, or average value of the oil pressure on each particular lap. So we can get a quick overview of the engine health during the stint. As you can see, in some points the minimum oil pressure was quite low actually, and we can now dive more deeply into lap, for example, 6, and see if it is just an outlier, maybe some malfunctioning sensor, or something is really wrong with the engine. So we can spot the issue before it occurs. We take the log, for example, from one stint on the endurance race, we quickly look through it. This would be basically really hard to spot in the graph log. Here we have the answer in like a flick of a finger. We could analyze the tire temperatures. For example, if the tire temperatures rise from the beginning and reach the plateau, or they rise and rise and rise and the tires overheat and overheat more and more, there are really endless possibilities with the run chart. We can also look stint versus stint. Some of you found some issues with the engine by looking at the oil pressure versus RPM. So this is another of the panels that can really highlight the issues with the car, but not only. Here I have a so-called traction circle. So the lateral G and longitudinal G. If the driver is less experienced, this wouldn't look like an egg or a circle. This would rather look like the driver stays in the middle. He doesn't use up all of the grip. So he brakes, he then comes to the neutral, he turns. This wouldn't be as smooth as in this case. If we have any outlier that we want to investigate, we can double click on the point. We should be able to double click on the point, sorry, and move to this particular point. Did I mention it's just a beta version for now? Yeah.
It moved in the graph, so.
It moved? Yeah. Okay, sorry. Okay. Another one of the overview panels. Here we have table report. I will show you how it works in a so we have each segment of the track generated from the reference lab, or we can have a sector instead. I'd like to look at sectors because for me personally, each segment, it varies a little bit too much. But with each sector, the data is more consistent. And we can define what values are shown. For example, in this case, we can see the lap time, the times of each sector on each lap. And we can see that the theoretically best lap, lap 7, didn't contain any of the best sector times. The best first sector was on lap 9. The best second sector was on lap 6, and the best third sector was on lap 3. So the theoretical time that the driver could achieve would be nearly half a second quicker, right? You've seen that on the run chart of the lap times were all over the place. This is another indication that there was something causing the driver to drive inconsistently. If this would be a practice session, this would mean slam dunk one of two things. Something was wrong with the car, something was wrong with the driver. But we can select any metrics to be highlighted in this table. So for example, we could see the engine temperature, the maximum engine temperature in each sector of the track, or in each segment. Then it's really hard to estimate what is going on. We can add some conditional formatting. For example, the worst is the highest, so the highest numbers would be highlighted in red. And we get, in this case, the differences are like 1 degree, right? So this is not a particularly interesting example, but maybe we have some issues in particular turns, or for example with oil pressure. We could also see if there are drops in pressure. For sure we will have lower oil pressure in the turns, but maybe there are some turns that are really, really low, or then it would mean that maybe the engine is starved of oil due to the lateral acceleration. The next panel is the track overlay. So to make it work, we have to have the reference track generated. And then we select the color that is used to draw the, not the color, but the channel that is used to draw the lap. In this case, we have speed. For sure, we would have slower speeds in the corners, faster speeds in the end of the straights, right? But what it gives you is the visual comparison if we have compare laps to compare selected. For example, here we have, is it longitudinal? It's lateral, but maybe we can select, no, it's longitudinal G. So we can see differences in the ways the driver braked on 2 laps. In the same corner, he braked a little bit earlier and for a little bit longer than on the other lap for the comparison. This is useful for the driver because once we talk about the log, it's a bit abstract, right? Because it's just a line. Here we have it directly specified on the track. So, okay, here I need to brake a little bit later. This was faster. One trick of the trade, we can select the time slip channel, so the difference between 2 laps as the color channel here. And this would highlight in blue that the white lap was faster, or in red that the red lap was faster. This is also a nice way to check, okay, he lost a lot of time braking to this corner, but he regained it all on the exit. So maybe a slower entry is better because you gain a lot on the exit of the corner. I know it because the color turns really deep blue, so a lot of time is lost in the middle of the corner, but it turns nearly white, so it's nearly the same at the exit of the corner. And one of the, I would say, most sexy features of the software. So the video analysis. To be honest, when I started to work with the data, I underestimated the power of the video. But there are things that are super hard to identify from the log, especially because we have the data from just one car. We don't have the context what is going on all around us, right? If we have the video, we know, okay, he turned a bit later here because somebody was on the inside. That's why I lost time. It was starting to rain more. That's why I lost time. We can see directly what were the differences between lines on each lap through the corner. And what is very special in our software is that we can synchronize the video with the data automatically. I will show you now how it works. So let me check. Yep. Auto-synchronize video and data. And now I will open the video. The video comes from the GoPro. And as you know, GoPro has a GPS sensor inside. So the GPS data is stored together with the video. And we will now use the GPS data from the log and from the video to synchronize them. Because not always the ignition is turned on together with the camera. It is possible to set up, but it's not always the case. Okay, the synchronization ended. We have a very good fit of 99%. Mm-hmm. The speed rises as the driver starts, right? So we have the synchronization, and the video corresponds to the data. Sorry, this is from the out lap, so I will now show you a racing lap. We can overlay data directly on top of the video, because now we need to look at the right side and on the left side and switch our focus from one panel to the other. With the data overlay, we see everything we need to see directly on the screen. As we can see, the driver is super brave. He doesn't use the brake at all. Of course, this is not the case. The brake signal was not connected to the ADU, of course. But yeah, it was a tough day for us. Now, in this part of the presentation, I summarized all of the panels, their usage, etc. But what if we want to extract more from the data? We have the possibility to make custom math channels, math constants, and aliases, and I will talk about them all in this part of the talk. Some maths is defined by default. We give it to the user, but the user can define his own. And we will start with the math channels. What is important to know is that math channel is the set of operations done on the recorded data. So we have previously logged data, missing the part that we seek for. For example, we have tire temperature cameras, and we would like to know the average tire temperature as a single value, not 16 points, but a single value. Of course, we would be able to define such channel in the ADU. But we may have forgot, or the customer didn't have it set up properly. And math channels in the data master work on the recorded data and use the recorded data to calculate new fields. It works basically like new column in Excel, right? We have the column with the data, we do some operations, and we gather a new data set. The channel addition is fairly simple, even though it's an advanced feature. So, as I mentioned, let's imagine we want to know the average tire temperature in each moment. Average temp front left. We can add the comment for us to later understand the formula, but in this case, the formula will be fairly simple, so I will not overcomplicate. We can select what is the quantity and the unit. Important to know, that is just a visual indication. So if we use this channel on the graph log, this will be shown that it is displayed in Celsius degrees. But if we want to convert into Fahrenheit, for example, we need to handle the conversion manually, either by transforming every channel, I will show you how to do it in a second, or by manual conversion. So this is just a visual indication. We will stay to the auto decimal places. This is like the most basic feature. We know that the tire temperature works in 5 Hertz frequency. So calculating it in 25 Hertz is too much, so we will switch to 5 Hertz. And now we have formula editor. Of course, I'm the creator of the software. I know the formulas. But the user didn't create the software, and it would be hard to remember all of the formulas. So what comes in handy is the functions selector. So we know we want the average temperature element. So for example, here we have all the temperature functions. Get, it returns a single point from the 16, the average, max, and mean. As you can see, there is a small help that indicates to the user what is the purpose of each function and how to use it. So in this particular example, I would like to calculate the average tire temperature. Now, the argument of the function is the temperature channel. So I want to calculate front left tire temperature. So now I need to find the temperature channel. Front left. DTC tire temp front left. Let's, for the sake of an example, don't close the parentheses on the end of the formula. We can now test the formula, and it highlights in red that there are missing parentheses. Because in a complex formula, it's hard to get it right, all right, just on the first try. So now we close it, test, no errors found. We can process later, further. The channel we've created is available now. We can use it as a normal channel. We can draw it on the graph log. So it was average front left. We can use it on the run chart, every visualization I talked today. So this is just as a normal channel. We can now use it to compare laps, etc. But I mentioned there is a possibility to change the unit. Let's create a new channel.
About the average temperature, how do you know how it's averaging? Is it averaging overlap over?
No, it's averaging in a single data point. So it takes, in every frame, it takes 16 points from the tire temperature, right? And it measures the average of 16 points at the single time. So it has 5 Hz frequency. It's not averaging over a period, it's rather averaging over space. Because this channel comes from the tire temperature camera, the infrared one that is mounted on top of the wheel.
And how do I know of all those functions? The question I asked about the averaging.
Yeah?
I have a lot of functions. Is it manual maybe? Yeah.
So you can basically check the help for every function. Is that what you ask, or?
Yeah.
This will be expanded in the future, this help, but you know, it gives you an idea for now. This is also well documented in the manual, so you can also check it in the manual to have the overview of all of the functions. Okay, and now let's calculate the speed in miles per hour, because we have some American friends in here and they don't like our units. So
what's a Celsius? What is a Celsius?
I will call the channel speed mph.
Yeah, you know me.
Okay. So let's make it on the example of the ECU speed. In the help, we have the default unit. So if we don't specify the unit or leave empty square braces, then it will be calculated in kilometers per hour. But we have some possible inline conversions to miles per hour or to meters per second. So I now specified that for this calculation, this channel will be used in miles per hour. Speed. From my understanding, 160 kilometers per hour is about 100 miles. Is that correct? Yeah. Okay, so we see the formula works. The math channels is basically a rabbit hole. We have multiple functions, logical, we have trigonometrical functions, we have derivatives, all kinds of stuff can be done. Basically, if you don't have something available from the software, in almost every case, you can calculate it using the mathematical channel. So this is a very powerful tool. And to somehow simplify the calculations, we implemented constants. Because some calculations may use, for example, a car mass or some physical constants. We have defined in the default maths the pi, for example. We can define also the Earth gravity, all kinds of constants. And we can name the constant car mass. For example, 1.3 tons, and we can select the unit. Now, we can use this value in all of our mathematical channels, so we don't need to specify 1,300 in every channel. We use the car mass, And what if we change the car, or we change something in the car? Here we have just one place to change it, and the calculations will be proper. Otherwise, we would need to go manually through every channel and check what was the, if we already changed the value or not. And as I mentioned in the beginning of the speech, the Data Master works with all our logging devices. And some channels have different names depending on where they've come from. For example, we have in ADU channel ECU.clt, but in Black it would be CLT. Or we have different setups. One car has an external sensor wired to the ADU, and the other doesn't have. What if we define the visualization with this particular channel? I will show you an example. So, CLT. And let's say the user defined his own sensor. Now, the software, if this alias, because that's what it's called, an channel alias, if this alias will be used in any point of the software, is it visualization or math channel, the software will check if we have the data from the external sensor. If yes, use this sensor for all the calculations or visualization purposes. If not, go further. Check if the CLT is available from the ADU, the Black, or the EMU Pro. So with one setup, we can analyze the data from all sources. Is it from different ECUMASTER devices or from different customers? We don't need to change it manually every time we use the software. So this is, I think, really boosting the versatility of the tool. Yeah, I talked about it and about the aliases as well.
Can this be stored? So the whole
yes. Yes, this is stored inside our project.
And can you export it and use it?
Exactly. If we open, here we have the button to export maths file. We can share only the maths file with our customers, or through different projects we can use a single maths channel that we defined only once. We can also group, like in the project tree from the ADU, we can group channels and constants and aliases, so it makes the managing of the whole maths project simpler. Oh, oops. Okay. In the beginning of my talk, I highlighted the issue that some of customers sometimes have. So for example, they didn't define the user-defined start-finish point, right? If the log is not split into laps, then it's really hard to, you cannot compare different laps. It's really hard to find some crucial spots, and basically the log may be useless. Data Master gives the user the opportunity to fix the issue. We have it's called lab editor. We can see the overview of the labs. From here we can also manage the automatically generated reference track. We can edit, just like in the ADU, we can edit the reference track, add new segments, delete existing ones. But the feature I would like to focus on is the start point editor. In this case, the start point was defined by the user here. And in fact, it is properly placed. But for the sake of example, let's just imagine that it was defined in the wrong place. We can simply drag the start point to any point of the track. For example, let's imagine that the start point is here. As you can see, the start-finish line changed, the reference track generated from this particular point, the laps were calculated in a different way, so the log is not lost. Now, if we exit the software, this particular log split will be saved together with the log, such as the bookmarks, they're also saved with the logs. And if the user opens the same log another time or with different project, this split will be loaded. So it's really a vital feature to fix the issues that some customers have. Also, if we don't have the reference track, we can manually move the start and finish of each lap. If there was a missing beacon, for example, we can split the lap into, we can move the start and the finish as we want. So this is very useful. For example, if we didn't have GPS signal, something was missing with the GPS, then we can, of course, it's not perfect, but we can split it into, for example, by top speed. Select always the top speed as the marker to split the log, indicating that this is the end of the straight, right? So this is not perfect, but it allows you to work with the log that previously would be useless. I will now discard all the changes I've made because this log is split properly. Okay. The last part is I would like to discuss the differences in different project types. Because as I mentioned before, the whole training was done in the circuit, but as I said before, we support different types of motorsport. So in circuit, we split the log into laps. In rally, we split it into stages that are open from point A to point B. And we can use the feature with the dragging of the start point. We can drag it on the GPS trace to the start and the other point to the finish, and we can mark the start and finish of the stage. And we can move on with the analysis. We can generate a, not reference track in this case, but reference stage. It will be split into straights, turns. We can use it to dive deep into the data from the rally as well, which is something that was really missing. In drag, the split will not be based on the GPS, such as in two previous cases. Instead, it will be based on the TPS input and on the speed. Once the software sees the throttle opens and the speed rises with some rate, it will mark it as the start of the run, and then it will calculate the distance along and place the markers in the 0 to 60 split, the 330 feet, the 1.8 mile, and this will be some kind of an analogy to the sector, right? So, yeah?
It's problematic because you have wheel slip or you might only have two wheels on the ground. So
yeah.
Are you still using GPS for speed?
For now, we use the ECU speed, which is not perfect, I know, but we have some plans to fix it in the future.
Okay, because that would be nice to have that because there's different tracks, different elevations.
Yes. There is a device called Draghi. We know that makes it quite well. So I think we will be able to improve the algorithm as well.
It was more or less the same question because you have the same issue with tractor pulling.
Yeah, yes.
If you use this dash lock, there's no standard module for tractor pulls, so you're going to use the module that's called drag racing.
Yeah.
And we also need the starting point and the finish line, but the speed is much slower, of course. We start with a very high wheel speed.
Okay, yeah, I see.
They start off with, let's say, 90 kilometers at a starting speed at the wheels.
Okay. I think we should be in contact after the training, because these are some cases that I don't personally have the experience with. So I would be really glad if we discuss this case further.
Sorry, why don't you use the GPS versus the speed for the drag? Why don't you use accelerometer?
Yeah, we think about improving and the ways to improve the algorithm, because not all drag races use the GPS, but I think we should try to use the GPS as well.
We'll talk about it, because there's some other ideas, for sure.
Yeah.
Talk about it.
And an interesting project type is a dyno pool, because if we have a log from the dyno, well, how to split it, how to compare different parts of this log. So basically, we have the strategy that we split the log into parts that was the throttle was like fully open and like more than 80%, and the parts that the engine was idling. And using it, you can compare different pools, see how the change in the parameters affected the data. And as it's a quite specific case, we can drag and we can move the splits around. So we can overlay one on the top of the other, because it's not like with the lab that also always starts and ends in the same way. We can move to highlight, to compare only the interesting parts, not the whole pool.
They say time axis offset. Is it?
Yeah, that.
Is it RPM?
Let me show you how it works, maybe. So I will now start a new project, a dyno project. I have some dyno test data. Okay. Well, sorry, something went wrong. I will start like from the beginning. And we can, in this case, you can see that the pools were slightly offset. This peak in, for example, the manifold air pressure, absolute pressure. So we can move one on top of the other and compare just those specific points. That's what I mean by time.
The timeline should be RPM.
Timeline should be RPM.
Yeah, so you can compare RPM.
Okay.
Can you
Choose. You want to say, let's say 4,000 RPM, and then you want to check all the other data.
Okay.
Initial timing, lambda.
That's a very valid.
This axis
Yeah.
overlay RPM exactly the same, so it's pretty much the same. Yeah, but it should be RPM.
Okay. Yeah. Thank you. That's why we gathered today, not only to train you, but also for me to gather your input. Because, as I said, I have the experience, especially in the circuit racing, but your input on both drag racing, tractor pulling, and on the dyno is very important and will help us make the software better for the user.
Can you do a similar time shift on a circuit data?
Not now, but
Sometimes you have a lap with a different length, you take a different line.
yeah.
You need to line up in like that box or something like that.
Okay.
I think you need to add a segment racing. Let's say a start and a finish line, not in the same region. You're designing a region that the data that acts like in a circuit. You have the start is also the finish line.
Yeah.
When you have, like, let's say, uphill race.
Yeah, that's supported by the Rayleigh project.
Yeah, rally allows you to do different starts.
Rally,
Yeah, there is a separate start and finish point. Okay.
So that's supposed to help him with tractor pulling, because that's what he needs. Start and finish.
But the start and finish are generated on based on the GPS. Do you have GPS? Okay, so maybe that will answer your problem. Okay. As I mentioned before, thank you for the valid input. That's really nice of you. Okay, And to sum up, I would like to point some key features of the software just for you to memorize. So one of the most important features is the availability to analyze the video with the automatic synchronization with the data. If the video comes from the GoPro, you can define mathematical channels that work on recorded data. Was somebody raising hand? Oh no, sorry. We have the support for the user channel, so the user can load the user-defined data without loading the separate project. We have really multiple advanced visualizations, so we can look at the data from different perspectives. And the panels are integrated, so when we move, we can move from one to the other, and they stay synchronized, as with the example that I double-clicked the bookmark and went to the log to see what was the point that I highlighted. Okay, so that brings me to the end of my presentation. Thank you very much.